Hi, I'm Dr. Martins. Glad you found me.
Hi, Dr. Martins. Dr. D told us that the density of water depends upon its temperature and salinity. But how does temperature make the water more dense?
Cold water molecules are packed together more tightly than warm ones, making cold water denser.
So do the density currents form near the north and south poles?
Exactly. The cold air at the poles cools the surface water, making it denser and causing it to sink.
What about salinity?
When ice forms in polar waters, it leaves behind salt, which increases the salinity of surrounding water.
The higher salt content makes the polar water denser.
I learned that evaporation also makes water saltier.
That's right. In areas such as the Mediterranean Sea, where there's little rainfall and lots of heat, evaporation removes fresh water and leaves extremely salty water.
Where does the denser water go?
The denser polar water sinks and creates the thermohaline circulation.
Thermohaline?
Yes, thermo for temperature and haline for salinity. The cold salty water masses that create this circulation form in only two places. The water mass sinking off Greenland is called the North Atlantic Deepwater, or NADW. The water mass sinking off Antarctica is called the Antarctic Bottom Water, or AABW.
Where do these currents end up?
They both sink down several kilometers while spreading out horizontally and moving along the bottom of the Atlantic Ocean. They eventually mix while circulating around Antarctica. Then they move into the deep Indian Ocean and finally into the Pacific.
So the water from the poles may one day end up on a beach in Hawaii?
I guess you can look at it like that. What goes down must come up. It takes the average water molecule 1,000 years to make the complete cycle.
Wow, that's a long time.
Yes, we call the cycle the global conveyor belt, and it has a large impact on climate.
I went swimming once and the water was really cold. My mom said it was an upwelling, but what's that?
The coastal upwelling that you experienced is different from thermohaline circulation. It only brings up cold water from a few hundred meters deep.
It's also not as cold as AABW or NADW. Coastal upwelling is generally caused by wind.
Is upwelling important?
Good question. Upwelling brings lots of nutrients up from deep water. We are researching the impact of nitrogen, a crucial nutrient, on Florida Keys reefs.
How does upwelling affect the reef?
It appears that there have been major changes in the health and community structure of coral reefs here in the Keys and throughout the world. By observing the nitrogen composition of sponges, we can determine the importance of different nitrogen sources.
Wow, you've given us a lot to think about. Thanks, Dr. Martins.
You're welcome. Good luck on your project.
Hi, Bianca. Thanks for meeting me here. I had a taping earlier today.
That's cool. I've had a little bit of experience in front of cameras. Dr. Adamet, we learned about density currents, but we need to learn more about surface currents. So what exactly is a surface current?
A surface current is water moving near the ocean's surface, above what we call the thermocline.
Thermocline. I know that therm has something to do with temperature.
Right, and cline means change, so a thermocline is a region of temperature change.
Where is the thermocline?
Typically between 50 and 150 meters deep.
So how do surface currents form?
Friction between the wind and the surface water causes that water to move.
We learned in the case of the mysterious red light about global wind patterns, and that winds blow in a certain direction depending upon where they're located on Earth.
Right. For example, the trade winds push the surface currents around in the tropics.
But are there other factors?
Oh, sure. Because the Earth rotates, there's turning due to the Coriolis effect.
Isn't that when the wind is deflected to the right in the northern hemisphere and the left in the southern hemisphere?
Yes. And another factor that steers currents is the topography, the hills and valleys on the ocean floor.
How does the topography underwater affect the surface currents?
I'll show you. Sit on the stool. Now don't try this without an adult, but I want you to stick your arms and legs out. And once I spin you, I want you to bring your arms and legs in close to your body, okay? You ready? What happened?
I spun slower when my arms and legs were out, and faster when they were in.
Topography does the same thing to currents. If a current flows over an underwater mountain, the water column gets flattened and compresses. That's you with your legs out. The water spins differently, and the currents get deflected.
Why are some surface currents cold and some others warm?
It depends on where the water's coming from. If it's coming from the poles, it's cold. If it's from the tropics, it's warm.
Do warm and cold currents affect the climate of an area?
It's a good question, Bianca. Yes, they do. For example, Ireland is pretty far north, and you might expect it to be cold there. But the Gulf Stream flows past Ireland, and the warm water heats the air, which helps to create a surprisingly mild climate. They even have palm trees in Ireland.
Really? With currents located in every ocean, I guess they could be responsible for bringing the tennis shoes and oil to our beach.
It's possible, but you got to be careful. The same current can transport things to different places.
How does that happen?
You dropped the balls at the same time and all in about the same place. They ended up in different places. Why?
Is it because there are so many different variables, such as the pits in the pavement, or even the shape of the ball?
Exactly. The same thing happens in the ocean. Tiny variations in the current can lead to large differences where the current might actually move things like your tennis shoes.
Wow, that's amazing. I'm curious, why does NASA study currents?
Earth's oceans have the greatest influence on climate, and only from space can we monitor the vast oceans on a global scale and monitor critical changes in the currents and the heat storage.
Why is that so important?
Well, the oceans cover 70% of the Earth, and the currents in the ocean are an important part of the water cycle. Any change in the water cycle can cause major consequences on our Earth.
How does NASA monitor the ocean?
We use different satellites to monitor things like currents, waves, temperature, and pretty soon even salinity.
That's really interesting. I'm always amazed at all the research NASA does to help protect our Earth. Thanks, Dr. Adamek. This information has been very helpful.
You're welcome. And call if you have any more questions.